Hello and welcome. This is our lecture video for September 18th. We're going to be talking about areas today. I've got a quick puzzle for you to get started here. Go ahead and try this puzzle. Pause the video. Your goal is to make the numbers 0, 1, 2, and 3 with 4 threes by swapping out different operations. Okay, so here's how we can do it. Let's get to 0. We start at 3. Maybe we add another 3, we're up to 6. Subtract a 3, we're back to 3. Subtract another 3, we are down to 0. All right, let's see if we can get to 1. I might do something like 3 plus 3. Now I'm up to 6. Minus 3. Now I'm back to 3. Divided by 3, and I'm at 1. But if I want to do it this way, maybe I should put parentheses around this part so I make sure I still go left to right and I don't jump out of order and do the division first, which is what PEMDAS says. Alright, to get a 2, we can do something like 3 times 3, we're up to 9. Minus 3, we're down to 6. Divide by 3, we're down to 2. And again, we need parentheses here to make sure we go in the right order. All right, last one, we need to get to a 3. So maybe we do 3 plus 3 again, we're at 6. Plus another 3, we're up at 9. Divide by 3, and parentheses here. These are just one possible solution. You can have fun with this, try to get a few more. All right, goal for today is to find the area of rectangles, parallelograms, trapezoids, and I threw triangles in as well today. Why are we doing this? Well, we're going to do it with numbers today so that we can do it with variables very soon because areas and perimeters with variables give us a really good opportunity to practice our skills of distributing and combining like terms and simplifying in a very visual way. All right, let's start with what is perimeter. Perimeter, write this in your notes, hopefully you got that out, is the distance around a shape. We can find it by just adding up all the side lengths. When we have a rectangle, one thing we should know about rectangles is that if this length is 12, then this length is 12 as well. Opposite lengths of the same dimension. All right, if this is 8 over here, then this has also got to be 8 feet over here. And now we can add them up. So 12 plus 8 plus 12 plus 8. This is technically each of these is feet, but I'll just add it up without the word feet. This becomes a 20. We can pair this off to become a 20. Together these become a 40, and now we can bring the unit back in. This is 40 feet all the way around. All right, what's the perimeter of this shape? This is a trapezoid, or at least it looks to be. Doesn't matter what the shape is, the formula is still the same. We add up all the way around. So I count 4 side lengths, so I gotta make sure I don't accidentally double count something when I do this. I'll start at this 8 and go around clockwise. 8 plus 10 plus 10 plus 18. And now we can add this, we can pair them off if we want. 18 plus 28. Add those together, that becomes 46. And now we bring the unit back in. This is 46 meters to go all the way around this shape. All right, hopefully we're feeling good about perimeter. Now let's talk about area. So how do we measure areas? So depending on the unit, we're going, of the side lengths, we're going to measure it in how many square units it would take to completely cover the shape. So if we're measuring in feet, we're going to measure the area by how many square feet it would take to completely cover the shape. And we have a formula for rectangles that's very easy to remember. Area equals length times width. And the trick to length and width is that these could be any two side lengths as long as they meet at 90 degrees. All right, so this looks to be 90 degrees, and we're told it is a rectangle, so we know that this is 90 degrees right here. So we can use 8 as our length, 3 is the width, or you could switch that around, it wouldn't matter, you get the same answer. So if area equals L times W, we're going to replace the length with 8. I'll keep the unit this time, times the width is 3 yards. And this becomes 8 times 3, 24. Yards times yards becomes yards squared. Or how we say that is we say square yards. So 24 square yards. And that is the area of this rectangle. All right, pause the video, try this one. Did you get 36 centimeters squared? Remember to put a little 2 there, hopefully. Now what do we do if the problem doesn't include units and we have a side length that's a variable? Well, we can still pick a length and a width and multiply them. So length times width is going to become 20 times s. But since we don't know what to write for the unit, we're just going to say 20s units squared. So that'll remind us that this is still a square unit, even if we don't know if it's inches or feet or meters or whatever. We still have to include that. All right, what is a parallelogram? It is a 4-sided shape. In which opposite sides are parallel, meaning that if I kept these two lines going forever, they would never cross. All right, and they would actually always stay the same distance apart too. All right, so this side is parallel to this side. We can show that by putting a little line through both of them, and this side is parallel to this side. Since they're different, parallel, we can do 2 lines to show that these are parallel. All right, these angles are not right angles. They don't have to be right angles for these to be parallel. So we can find the area of a parallelogram by, instead of doing length times width, we do something called base times height. Since nothing met at 90 degrees, we add in a dotted line that does meet at 90 degrees. And that essentially gives us a length and a width to multiply. Because this isn't a true width, we just call it the height. So area equals base times height. We see an example here. Feel free to pause the video and copy this one down if you want. Let's find the area of this parallelogram. This 15 is our base, and this length down here would also be 15, in fact, and this 8 is going to be our height. Base times height is going to become 15 inches times 8 inches, which, let me double check that one, 8 times 15, 120, and then inches times inches becomes inches squared. Okay, formula for the area of a triangle is base plus height divided by 2. That's not right. I found this slide on the internet, and this, I guess, goes to show you can't trust everything you find on the internet. I assumed it would be right, but this is not. It should be base times height. Base times height divided by 2, or sometimes we write it as 1/2 base times height. All right, so we fixed it. Now you'll include that in your notes. Let's find the area of this triangle. When this meets at a right angle, then this side length is the height. Otherwise, we use again a dotted line, and that's our right angle. All right, so we can use the 7 as our height. We can use the 6 as our base, and then the area equals base times height divided by 2, which equals 6 inches times 7 inches divided by 2. I won't write the word inches, but we'll know it's there, which equals 42 over 2, which equals 21. And now we'll bring inches back in the form of square inches, which should make sense because if we extended this over and made it into a rectangle, then it would be a 6 by 4 or a 6 by 7 42-inch rectangle, and we're only keeping half of it over here. All right, area of a trapezoid. This one's a tricky one. What you do is base 1 plus base 2 divided by 2 times the height. So and your bases are the two parallel sides. So this will be base 1, this will be base 2, and the height is a dotted line that meets at a right angle. So this will be our height. The 7 and the 5 are just distractors here. So when we plug these numbers in, we get 6 plus 8 divided by 2 times 4, which equals 14 over 2 times 4, which equals 7 times 4, which equals 28. We don't have any units, so we have to say units squared for this problem. All right, I'll give you a few more to practice here. That's that for this lecture video. Have a good rest of your day.